Hello all. This video talks about cumulative distribution function abbreviated as CDF. So in this video we will see what is meant by a cumulative distribution function and what are the properties of a cumulative distribution function. Now going for the definition. So what is meant by an cumulative distribution function? Say suppose x is going to be a random variable which can either be continuous random variable or it can be a discrete random variable. So x is a random variable which can either be a discrete or a continuous random variable. Then the probability of x less than or equal to x is called the cumulative distribution function or distribution function of the random variable x, and it is denoted by capital F of x. So now we have the definition as the cumulative distribution function or the distribution function of the random variable x denoted by capital F of x is defined as probability that the random variable x takes the value less than or equal to an element called x. Now if this is going to be discrete, our random variable x is going to be discrete, then how is this cumulant obtained as? It is nothing but x less than or equal to x, which means add all the probabilities until this value x is obtained from the base. So it is the addition of all the probabilities pi's, the summation having over I, where my xi is going to be less than or equal to the value obtained is x. So you add all the probabilities until this x is reached. So say suppose for example we have x less than or equal to 3 and my random variable x takes the value 0, 1, 2, 3, 4, 5 and so on. So you have x less than or equal to 3. So all the probabilities addition. So this is going to be my p of x. So it will be addition of p1, p2, p3 and p4. So you add all the probabilities till this point called as 3. And for a continuous case, if x is going to be a continuous random variable, then you have the same to be integrated the function f of x dx from the base range minus infinity to the point called as x. So what is this x now? X is the upper limit of your integration and it will be integrated till the point called as x. So say suppose your x values between a less than x less than b, that is defined in the interval from a to b. So from a till the point x the integration will happen. So that is how it is defined for an continuous case. So the addition of all the probabilities until the point x is called as the cumulant. Cumulant means additive of, cumulative of. Now having got the definition, we move on to the properties. Now moving on to properties of a cumulative distribution function. First property, the cumulant always begins the counting with 0 and it starts counting, moves on and on and on and when it reaches the final value, it always ends up with 1. Why this is equal to 1? Because we know that when we add all the probabilities, the summation value is always equal to 1, or the integration value of fx is always equal to 1. So the cumulant always takes its values between 0 to 1. Property number 2. If f of x is going to be the cumulative distribution function, then this f of x is a non-decreasing function of x. So what do we mean by this? Whenever we have a less than b, then the value attained by f at the position a will always be less than or equal to the value attained by f at the position b. So f of x is a non-decreasing function. Its values is going to be less for a lesser variable and more for a greater variable. Number 3, f of minus infinity is 0 and f of plus infinity is 1. We can also rewrite this as limit x tending to minus infinity, f of x is 0, and limit x tending to positive infinity, f of x is always 1. This is because we know that at the leftmost value of the range minus infinity to infinity, the value of f of x cumulant is always 0, and at the rightmost value at the infinity, as we move towards, the value will get closer to the value of the end probability called as 1. Property number 4. If x is going to be a discrete random variable in such a way that you have x1 less than x2 less than x3 and so on, then the probability at any position p of xi can be got by the subtraction of the two consecutive CDF, namely f of xi minus f of xi minus 1. This is because the cumulant gets added up stage by stage. So if you want the probability at one particular stage, then you just have to take the difference from the last stage. So you will be getting the difference between two values. So the probability at any position x equal to xi is got by the subtraction of the cumulant of the consecutive terms. Number 5. Whenever x is going to be a continuous random variable, then probability of a less than or equal to x less than or equal to b can be given as f of b minus f of a. That is, you subtract the end values of the probability, then you get the total occurrence of the probability between these two values. And now comes the sixth and the most important of the properties, namely how to associate a CDF with a PDF, that is a cumulative distribution function and a probability density function. Okay, so the relationship is given as f dash of x is equal to small f of x. That is, the differentiation of the cumulant will give you the probability density function. This is because we know that it is the integration which gives you capital F of x. So when you want the small f of x, what you will have to do is shift it to the opposite side. So what is the opposite operator for your integration? It is differentiation. So when you differentiate your f dash of x, then you will be getting your small f of x. So these are the properties which can be effectively applied to solve problems in properties of random variables.